Energy. Energy is basically the capacity to do work. Energy and work often mean the same thing essentially. Energy and work. There is a formula for energy or work, and it's work done equals force times distance moved in the direction of the force. So the force is measured in newtons. Distance should be measured in meters, and if you've done that, your unit will be in joules or newton meters. They're the same thing. Joules equals newton meters. This can be put in a triangle to help manipulate the formulas. So you'll have the symbol for work at the top is capital W, the symbol for force is a capital F, and the international symbol for distance is little s. You can rearrange the formulas to make W, F, and S the subject. Here's the answers if you want to give it a go. The different types or different forms of energy are as follows. One example of energy is stored energy, and this is chemical stored energy, like in some matches, for example. Another type of stored energy is as a result of being high up. So, for example, if you have Superman at the bottom, he's got very little stored energy. But when Superman goes to the top of the building, he has gained energy, and he has gained gravitational potential energy. And this Superman can't fly, by the way. And this Superman, when he jumps off, his gravitational potential energy gets changed into kinetic energy or moving energy. And of course, that eventually will end up him traveling very, very fast. And I'm afraid at the end, he will turn into heat energy and sound energy at the bottom there. Another type of energy there is sound energy. That's a type of moving energy. Kinetic energy, shown by the unicorn here, moving very, very fast. We've also got energy in electricity, and of course that's really useful electrical energy because we can change it to so many different types. Chemical stored energy, like in fossil fuels, can of course be changed into heat energy, light energy, and sound energy. So there's two main groups or forms of energy. There's stored energy, so chemical potential energy, gravitational potential energy, elastic potential energy are all examples of stored energy. Elastic potential energy, by the way, is the energy stored in springs and catapults. And the next five are examples of moving energy. And perhaps the most important ones there are kinetic energy and heat energy. Kinetic is moving, heat is what most energy tends to end up as. Right, the key knowledge you need to know about this and you need to memorize is that you cannot create and you cannot destroy energy. All you can do is change it from one type to another. This is known as the law of conservation of energy. So with energy, you can't create or destroy it, but you can transfer it into other useful forms. You can also store it. But it can also be dissipated or wasted. Dissipate means spread out, okay? And normally heat gets wasted in the form of, energy normally gets wasted in the form of heat, okay? It's less useful when it's spread out over a long distance. If it's concentrated in an area, it's very useful, but if it's spread out over a wide area, it's not useful at all. Please make sure you realize that things heating up because of wasted energy is not the cause of global warming. That's caused by something entirely different. Here we're looking at an example of energy changes. So we've got the energy in petrol. Well, it got its energy initially from the sun that shone a long time ago to create fossil fuels. And the fossil fuels can then be made into petrol. That can then be put in the car to make the car move. So the car gains kinetic energy. Eventually the car stops and all that energy ends up as heat again. And of course that can be shown in the form of an energy chain. So you've got light energy being changed into chemical potential energy stored in fossil fuels. And that of course takes millions of years to do that. And then that energy can be released in the engine of the car, and when that happens the car engine creates kinetic energy or moving energy, but it releases mostly heat and sound, mostly heat. The car moves, and after a period of time of course the car will stop, and then at that point all of the energy given to the car will have ended up as heat. And of course that heat is spread out over a large volume, a large area, and isn't useful. We say that energy has been dissipated or spread out. And in most cases you end up with heat energy just heating up the surroundings. Now it's important to realize that at no point have we created energy and at no point have we destroyed it. All we have done is change it from one type to another. We've transferred it and eventually it ends up as being dissipated. Use those good